when we get back in January. So make sure you're here. That's all I'm saying. All right.
Would it by, like, can you take it early? Like,
Yeah.
Okay.
Yeah. All right. So here we go. So this is chapter 5. This is special relationships and triangles. Triangles have a ton of properties, and everything you guys learned about triangle proofs and everything like that, we're going to build upon for the rest of the year. So I will always come back to, hey, are these triangles congruent? And we'll look at the picture and investigate and be like, yeah, they're congruent by side, 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 or they're congruent by side, angle, side, or HL, or something like that. And so we can always come back to, are the triangles congruent? Because if they're congruent, we know a whole lot more about these shapes, okay? Everything builds upon triangles. And it turns out, you know, we have a whole course of study, trigonometry, that builds on triangles. The entire course is about triangles, okay? They are the root of everything. So it turns out that triangles have a lot of special relationships, and we're going to learn about all of them. We're going to do some more constructions as well by hand, but on the computer as well. And so all of these, this first page, is all the vocabulary we're going to be learning. And so this is something we'll fill out as we go. And today we're going to learn about the mid-segment. So turn the page. All right. So this is mid-segment. So be able to apply and use the mid-segment theorem and its properties. So a mid-segment, let's analyze that word just for a minute. What do you suppose mid-segment refers to? The middle. Very good, ladies and gentlemen. Genius points there. All right. A triangle mid-segment. The triangle mid-segment is a segment connecting the midpoints. Okay, midpoints of two sides of a triangle. So you can see here, DE is what we would call a mid-segment, all right? It is a mid-segment because D is a midpoint. I know it's a midpoint because my two segments on either side are the same. If DA is a length of 3, what's DB?
3.
Also 3. And over here, I know that E is a midpoint, and I know that because of the markings here. These are also congruent, so if this side is 4,
That is also 4.
yeah, BE is also 4, okay? So a mid-segment connects the midpoints of opposite sides. So DE is a mid-segment. Segment DE is a mid-segment. And again, you see the word mid, we think middle, right? Like it's just pretty natural, okay? Now it turns out that if a segment joins the midpoints of two sides of a triangle, that's very long. If a segment is a mid-segment, okay? If we have a mid-segment, it turns out the segment is parallel to the third side and half as long. These are the properties of a mid-segment. So in the diagram above, DE is a mid-segment. It turns out that DE, segment DE, is parallel to what? AC, yes. AC, the third side, the side that it doesn't touch. You can see, does it look parallel? Yeah. So we have parallel lines, ladies and gentlemen. It always comes back to parallel lines. Those two segments are parallel, so we have parallel line properties happening here, okay? So we have parallel lines, and I'm going to say the third, it's half, this mid-segment is half the length of AC. I don't like saying that because that's a weird way to say it. But let's do some numbers here. If the midsegment is 5, how long is AC?
10.
Hey, it's 10. Okay, twice DE, twice segment DE. If we take DE and double it, it equals the measure. I guess I shouldn't have the segment bar above there. Twice DE is equal to the length of AC. So if we double the midsegment, we'll get that third side length, okay, which is kind of interesting. So not only does it join the middle, the halfway point, it's also half as long, which is kind of interesting, okay. And pretty easy, right? It's the halfway points, it's also half as long as the third side, right? It's kind of an interesting way to think. You can half it, yeah. So if we know the long side, then we split it and divide by 2, okay. So it's kind of interesting. Let's look at number 2. Identify all pairs of parallel segments. Let's look at this picture very, very carefully, ladies and gentlemen. I have some congruence marks. GJ is congruent to JF. Tell me about J. Midpoint. I have some congruence marks on GK and KH. Tell me about K. Midpoint. So here, JK is called a midsegment. All right. So JK, segment JK, is parallel to what? Yes. The third side down here, and it looks pretty parallel too. You don't have to think too hard or imagine too much to say that they are parallel. All right. So again, J is a midpoint. Tell me about L. It's also a midpoint. So here, JL is
parallel to GH.
Yeah, it's a midsegment. JL is a midsegment, and it's parallel to this side over here, GH. So JL, segment JL is parallel to segment GH. It's also half the size. All right. And last here, yeah, we have another mid-segment right here. KL is parallel to GF. Yes, there it is, right there. They are parallel. So GF. All right. KL is parallel to GF. All right, let's look at number 4.
Oh, sorry.
Okay. All right. Reading carefully, ladies and gentlemen. So important that you're reading super carefully. And anytime you read something, what do we need to do? Mark our picture up. Yeah. So F, G, and H are midpoints. F, G, and H are midpoints. I'm going to mark that on my picture. If F is a midpoint, I know CF and FB must be congruent. If G is a midpoint, I know CG and GD must be congruent. And if H is a midpoint, HE and HD must be congruent. So I have all these mid-segments. Now, it turns out that FG equals 9. FG is 9. So I'm going to mark that on my picture. The length of the segment is like 9 millimeters. And GH has a length of 7 millimeters, whatever it happens to be. The length of the side is 7. And CD is 24. CD is this long side. It has a length of 24, maybe millimeters or whatever it is. Okay? So, we know a few things here. Here, GF is a midsegment. What is the length of the third side then?
18.
How'd you get 18?
9.
It's, yeah. It's double the side that is its midsegment. It's twice its midsegment. So 9 times 2 is 18. So DE is 18. Let's see. I have GH here, we know was 7. Again, that's a midsegment. It's a halfway point. Tell me about CE.
14.
How do you get 14?
7 times 2.
7 times 2. Very good. It's 14. It is twice the length of its midsegment. CE is 14. Now, FH right here is 12. How'd you get 12?
24 divided by
Yeah, we have the whole side is 24. Our midsegment is half as long. So it is 12. Now, what's the perimeter of triangle CDE? CDE, the big triangle. What's perimeter? Yeah, it's 24 plus 18 plus 14. We know all 3 side lengths. We just have to add them up, and what do we get? 56, okay? Easy or hard?
Easy.
Okay?
It always got one that has like 4 different.
Well, a triangle can only have 3 midsegments, right? 3 sides?
Like 2 triangles.
Oh. All right. Okay, so number 6. Let's look at number 6. Look at my markings. What information do we have?
6x plus 31 is the midsegment.
6x plus 31 is the midsegment. We know it's a midsegment. Are they equal to each other?
No,
we need plus that equals 180.
Yeah,
12x plus 62. Okay, because you've got to double it? Yeah, okay, 2 midsegments. So twice our 6x plus 31. The midsegment is half as big. If we double it, we'll get that third side. It's bigger. This is clearly longer than the midsegment, right? So twice the midsegment equals 19x minus 36. Okay? Does that make sense to you? All right.
Yes, ma'am.
All right, double your midsegment. Maybe write that down. Double the midsegment. If you can, that's the easiest way to go. Could we also half the third side?
Yeah.
Yeah, but I don't want to half 19, right? I want to create fractions. All right, double the midsegment. That's the thing here. So we get, let's see, 12x plus 62 equals 19x minus 36. What do you want to do to solve? I'm going to minus the 12. Sure, I heard that first.
What? It's a lot easier. Yeah.
You can do it either way, but 62 equals 19 minus 12 is 7 x's minus 36. And then what do we need to do?
Plus 36.
Add the 36. All right, so I get, let's see, 62 plus, that's a 36 is, you're right, thank you, 98 equals 7x, and then divide by 7 and we get, you still get the same thing, yeah. Yeah, you can spin it around. That's the symmetric property, right? We can just spin things around this equal sign. There's lots of options there. All right, turn the page. Let's look at number 9. Let's look at so first of all, let's look at number 9 here. It says, reading carefully, gentlemen, reading carefully. Segment MN, locate MN. MN and NO and MO. MO. Segment MO are mid-segments. Very important we pay attention. Mid-segments. We got parallel lines and half as long. All right, mid-segments. We want to find the perimeter of triangle JKL. JKL is the big triangle. So our job is to find the perimeter of the big triangle. How do we start this, ladies and gentlemen?
MN is 49, so if we double that, we can get JL.
Okay, so we know that MN is 49, it's a mid-segment, and if we double that, we can get JL. All right, so 49 doubled equals? 98. Okay, so we've got one side of our big triangle. What else do we know?
NO is, it would be 84 for JK.
Okay, so we know NO is 42, and so its third side, its parallel side would be twice that. Double the mid-segment, we get 84.
And then 12x minus 2. How's it 13?
So what, okay, so numerically we've got just numbers. It's easy to just double the numbers. What do we do for our algebraic side, 6x minus 1? What do we have to do with that mid-segment? Double the mid-segment. Oh, so twice 6x minus 1 is equal to KL. 13x, thus is the nature of algebra. And we have to solve. Alright, so they're not supposed, we have to solve for the value and then plug it back in to get the number, the length of the side. Alright, let's distribute. So we get 12x minus 2 equals 13x minus 10.
Minus the 12.
Minus the 12x, alright. So I have negative 2 equals 1x minus 10, and then add 10, and so we get x equals 8. Okay, is x the length of the side? No, it is not. What do we have to do with our value of x? Plug it in. So we get 13 times 8 minus 10.
94.
Is it 94? Okay, so 94. All right, so how do we find the perimeter of triangle JKL? Add the outsides up. We've got the 94, the 98, and the 84. 94 plus 98 plus 84 equals 276. Okay?
Do you have a cheat sheet up there? Or was that like all mental math? Cheat sheet.
I have a cheat sheet.
That's what I can figure out. So like,
All right. Do you have a question on that one? Good? All right, mid-segments are parallel and half as long, right? Double the mid-segment is the phrase? Double the mid-segment? Okay, let's do number 10 here. Now, we've been talking a lot about the half as long, or double the mid-segment. All right, double the mid-segment. We have not addressed parallel lines. Find the measure of each missing angle. Ladies and gentlemen, now we're back to angles. These are not lengths of sides. We're talking about angle measures, okay? Now, looking at my picture, tell me about this point right here. It's a midpoint, and on this side it is also a midpoint because it's been divided, so I have here a mid-segment. And if I have a mid-segment, whoops, the daisy. If I have a mid-segment, then I have parallel lines. So I have a parallel line and a parallel line. These two lines are parallel to one another. And now you have to be very good here.
so would the measure of angle 4 be 59?
Yes, why?
Corresponding.
Yes, very good. Right here, mark your picture, ladies and gentlemen. We have parallel lines. I have a transversal down here on the bottom and 59 degrees and angle 4 are corresponding angles. Corresponding angles are congruent. So angle 4 is also 59 degrees. Okay, corresponding angles are congruent. Mark your angles. Tell me about some other congruent angles. No.
Angle 3.
Mm-mm.
Could you just reference angle 2 is like 180 minus?
Yes.
Ooh.
But there's another pair of corresponding angles. 1 and 2. Angle 1 and angle 2 are also corresponding. All right? So now, Maggie said, can't we use the 127 to figure out angle 2? How do we figure out angle 2? 180 minus 127, yeah.
Which equals 53.
Which equals 53. So the measure of angle 2 is 53 degrees, 53. All right, what's the measure of angle 1?
53.
Also 53. All right, 53 for angle 1. Now, I have here the tippity top of my little triangle. Yeah, so can we figure out angle 3?
Absolutely.
Absolutely. So the measure of angle 3 is 180 minus 59 minus 53. Yeah, it's minus these two, 59 and 53.
68.
So the measure of angle 3 is 68. Thank you. All right. How do we figure out angle 5 here?
180.
180 minus 59, right there. Angle 4. So 180 minus 59. 180 minus 59 is 121 degrees. Okay. So it's really important that you're able to identify the corresponding angles. Will you please look at number 11 and mark your corresponding angles congruent, please? It might help to mark your parallel lines very clearly. Highlight those parallel lines. We have parallel lines. What are the corresponding angles?
2 and 4. And 1.
Yes, angle 2 is congruent to angle 4, and also angle 1 is congruent to angle 5. You must be able to identify your corresponding angles, all right? Corresponding angles are congruent. Also, what are angles 3 and 4? Same side interior. Same side interior. Angles are? Same sides are supplementary. All right, same side interior angles are supplementary. So again, these are things that you can use when we're solving these mid-segment problems. Let's go down and do the last one here, number 15, okay? All right, number 15. What is UV?
Parallel to RT.
UV is parallel to RT. This is true because it is a mid-segment. Very good. It's half as long, but it's parallel. And they are giving me angle measures. Ladies and gentlemen, I'm seeing a little bit of confusion. Angle measures, because of the degrees here, these are angles, not side lengths, so don't confuse yourself. Tell me about these two angles, which is right here, the 6x plus 1 angle, and our x plus 4 angle. What kind of angles are those? Same side interior. Same side interior angles are supplementary, okay? Which means, what equation can I write with these angle measures?
7x plus 5.
How'd you get 7x plus 5?
6x plus 1 plus 7x.
Plus x plus 4, yeah. So the 6x plus 1x gives you the 7x, and the 1 plus 4 gives you the 5. All right, so adding those together, it equals 180 degrees, okay? We can go ahead and solve then.
7x equals 175.
Mm-hmm.
And x equals
25, good. Am I done?
no, you have to plug it back in.
Yeah, okay, so RTV is right here. So the measure of angle RTV would be 29 degrees. 25 plus 4. Tell me about angles on number 14.
Corresponding.
Corresponding angles are congruent. These are corresponding angles. So what's the equation we set up for corresponding angles?
9x plus 2 equals 15x minus 15.
Yes. All right. So you have to be able to recognize the difference here. They're giving us corresponding angles and they're equal to each other. Here they're giving us same side interior, so they're supplementary. So everything we're doing is building upon stuff we've already learned, right? All right, tell me about a midsegment.
It is the
Half of the third side. Okay. So we can double the midsegment easily. All right, tell me more about the midsegment. Connects to midpoints, good. Parallel. It's parallel to the third side and half as long. Parallel, parallel, parallel. All right, very good, ladies and gentlemen. You have adult math.